Hello, ma'am.
Hi Akib, how are you?
I'm fine now. How are you?
Yeah, I'm good. Okay, so we were discussing theory of equations, right?
Yes, ma'am.
I'll be taking few more questions from here. All the important concept which is related to this chapter we have already discussed. However, there is a possibility of like getting more different types of questions from here, but that includes the concept of sequence and series. That includes the concept of conic section, everything. So first you need to know those concepts at first, then the question which are related to this theory of equation, which is also related to that one, you will be able to understand that time in a better way. So I'm taking few more questions which you will be able to understand now, and then we will be moving ahead with the next chapter, that is sequence and series. Okay.
Yes, ma'am.
Just a moment, let me share the screen.
Okay.
Can you see the screen?
Yes, ma'am.
Okay, so let's start. Last day, this one was the question which we were discussing. Have you done this one?
No, ma'am. Actually, I was having exams,
Okay. You,
so I was not
uh,
able to.
you were having exams, right?
Yes, ma'am.
Okay. So you will be able to do this if you have noted down the hints. First, try it and do let me know. Okay.
Okay.
Okay. So the next question we are going to take over here is, just a moment. Yeah. If alpha, beta, and gamma are three consecutive terms, of a non-constant GP such that the equation alpha x square plus 2 beta x plus gamma is equals to 0 and x square plus x minus 1 is equals to 0 have a common root. Then alpha beta plus gamma is equals to first option is 0, next one is alpha beta, next one is alpha gamma, and after that we are having beta gamma. Okay, this one is our question. As you can see on the screen that alpha beta gamma are three roots of the equation. Yeah. Okay, so here let's read the question carefully and let's try to do it. So here the question says that alpha, beta, gamma are three consecutive terms of a non-constant. GP means geometric progression. So do you know what exactly is geometric progression?
Yes, ma'am.
What is that?
Ma'am, R, like R is equal to D2 by D1. If two of them are equal, then they are called GP.
Yeah, there will be instead of just like the arithmetic progression, there is a geometric progression. In arithmetic progression, we were having common difference. Here we are having common ratio, right?
Yes,
So basically the geometric progression looks like AR, AR is square, AR cube. This is the general form of geometric progression, right?
yes, ma'am.
Okay. So here it says the roots, that is alpha, beta, gamma, are three consecutive term. That is, it's like first, second, third. It's like this one, the consecutive term of a geometric progression such that, so since it's a three consecutive term of a geometric progression, we can take it like alpha is equals to, let's say alpha is alpha only, keeping alpha as a alpha only. The next term, that is beta, can we take it as a alpha times r?
Yes, ma'am.
Because there must be a common ratio. So whatever is the first term, and since consecutive term of the geometric progression looks like this one only, so if the first root is alpha, other root will be alpha r. Another root will be alpha r square, right?
Yes, ma'am.
So we are saying that beta is equals to alpha r, and we are saying that gamma is equals to alpha r square. Let's write it properly. Maybe we need to use this information after this. So we are saying since alpha, beta, gamma is in geometric progression, we are taking alpha as a alpha only, beta is we are taking alpha r, and gamma we are taking alpha r square. Just three consecutive terms of a geometric progression such that this equation is equals to 0. Okay. So here we can see this equation is given over here where alpha, beta, gamma is there. So if we will be substituting alpha, beta, gamma value over here according to the geometric series. So let's substitute it alpha x square plus 2 beta x plus gamma is equals to 0. This is one of the equation. What exactly the question says that there are two equation and both are having the common root. then we have to show this condition. We have to show this is equals to which option. Is it 0? Is it alpha beta? Is it alpha gamma? Is it beta gamma, or what? So what exactly the question says? There are three roots, alpha, beta, gamma, and these three roots are in geometric progression, such that the given equation, two equations are there, this and this have a common root. Okay, then we
Yes,
have
ma'am.
to find the value of alpha in bracket beta plus gamma. So let's do that. If we will be substituting the value of alpha, beta, gamma according to the concept of geometric progression, what we will be having? So alpha x square, alpha I am keeping as it is, beta, just a moment. So let's substitute the value of alpha, beta, gamma over here. So we are having beta as a alpha r. So let's write it alpha rx. Gamma is a alpha r square. So let's write it alpha r square over here is equals to 0. Is it clear so far?
Yes, ma'am.
Now let's see what can be done over here. How can we simplify it? So alpha is there, alpha is there, alpha is there. So can we take out alpha as a common?
Yes, ma'am. Can we just plus these both? Alpha x square plus alpha x square?
Alpha x square plus this
No,
alpha r
okay.
square.
No. Yes, sorry.
No, we cannot, because x square r square is there. So like term is not there. Okay. So one thing
Yes,
we
ma'am.
can do over here, we can take out alpha as a common, right?
Yes, ma'am.
2rx plus r square is equals to 0, right? If you will focus on this one, does it look like a plus b whole square formula?
Yes, ma'am.
So let's write it a plus b whole square formula, and since alpha is just a constant, root means it's just a value, we can take that as a 0. So we can say all x plus r square is equals to 0, right?
Yes, ma'am.
From here, what will be the value of x? Is it minus r,
Yes, ma'am.
right? So we ended up getting x as a minus r. Now let's see what can be done for with the other equation. Why the other equation is also given, and it's written in the question itself that both equation have a common root. Okay. So the other equation we are having as x square plus x minus 1. We are having the other equation as x square plus x minus 1 is equals to 0. And in the question it is written that both the equation, that is equation number 1 and equation number 2, are having common root. So this is one of the root. X value means the root only, right?
Yes, ma'am.
Root means whatever solution we are getting, whatever value of x we are getting. So if we are getting x as a minus r, that is one of the root. And since both are having same root, common root, then that means this is also the root of equation number 2, right?
Yes,
Since
ma'am.
x equals to negative r is also the root of equation 2 equals to minus r, we can substitute it over here. Root means that only that it will satisfy the equation, right?
Yes, ma'am.
So let's substitute it, minus r whole square plus minus r minus 1 is equals to 0. We will be having r square we will be having negative r, we will be having again minus 1 is equals to 0. We can say r square is equals to r plus 1. This is, let's say, equation number 3, or one condition we have got. Let's keep it aside for a while and let's see what exactly we need to find. We have to find alpha in bracket beta plus gamma's value. Okay, so we have to find alpha in bracket beta plus gamma. This one's value we have to find, whether it is 0, whether it is alpha beta, whether it is alpha gamma, whether it is beta gamma. We have to do something over here. We have to do the simplification over here to get the value of this one. So alpha, if I am keeping alpha as a alpha only, and beta and gamma, due to geometric sequence, we have taken the general form, that is beta is alpha r and gamma is alpha r square. So beta is alpha r and gamma is alpha r square. Okay.
Yes, ma'am.
So we are having alpha, alpha can be taken out as a common. So we are having alpha is square, right? And in bracket we are having r plus r square, right? Right?
Yes, ma'am.
Yes, ma'am.
Here, if you will see equation number 3, can we say r square is equals to r plus 1? So if we will be multiplying both side by r to customize this equation number 3, we will be having r cube is equals to r square plus r, right? This one's value I was searching. That's why I have done the multiplication. Okay.
Yes, ma'am.
So we ended up getting alpha square r cube. Why we did so? Because see the options, alpha, beta gamma. So that's why we are trying to just remove that plus and minus from there. Okay. Now
Yes,
we are
ma'am.
having in hand already that there are 3 roots, that is alpha, other one is alpha r, other one is alpha r square. This is beta's value, this is gamma's value, which we have taken according to the given condition. So alpha square r cube, can I write it as alpha r square? Okay, let's keep alpha as a alpha only, and then alpha, one more alpha. Is there beta gamma option? Yeah, let's see whether we can make it as a beta gamma or not. So beta gamma will be what? According to this one, beta gamma will be alpha r into alpha r square, right? That means alpha square r cube, right?
Yes, ma'am.
So this can be written as beta gamma, right?
Yes, ma'am.
Is there any option? Yes, it was there as a option number 4. So that is the correct option. Got it?
Yes, ma'am.
It's clear, right?
Clear, ma'am.
So let's see the summary what we have done. Alpha, beta, gamma were the 3 consecutive terms of a non-constant. GP means geometric progression. As you know, geometric progression, the general form is first term like AR square, AR cube. It looks like this only. So we have taken the first root is alpha, the second root beta became alpha into r, gamma became alpha r square. Now we were having two equations, that is alpha x square 2 beta x plus gamma, that is 0, and x square plus x minus 1 is equals to, these two equations are having a common root. Okay, so whatever alpha beta gamma we have assumed, we have substituted it in first equation and we ended up getting x is equals to minus r. And since both the equation are having a common root, so we are saying this is one of the root. So the other equation is also having the same root. That's why we are substituting x value as a minus r in other equation. And we ended up getting equation number 3. Now it was asked in the question that alpha in bracket beta plus gamma, do the calculation of this one. So we have done the calculation of alpha in bracket beta plus gamma by substituting beta and gamma value, and there we have done the substitution by using our equation number 3. That's it.
Yes,
Okay.
ma'am.
Okay. Let me take one more question. So the question says the set of all real numbers x for which x square minus mod of x plus 2 plus x is greater than 0 is option A, negative infinity to negative 2 union 2 to infinity. Option number B, negative infinity to negative root 2 union root 2 to infinity. Option C is negative infinity to 1 union 1 to infinity, and option D is root 2 to infinity. Just a second. Okay, so here let's solve the equation. Since the modulus function, as you can see, the set of all real number x for which this one inequality is given, and we have to solve this inequality to get the value of, to get the range, or to get the like in which interval x will lie. This inequality is having quadratic form, that's why it's here in this chapter. Okay, so let's continue with that. Can we say what is the meaning of this modulus function, mod of x plus 2 or absolute value of x plus 2? What's the meaning of that?
The answer what will come will be in positive.
It will be positive. Okay, so we can say yes, if there is any number, let's say if there is a number negative 2, then the result will be positive 2 only. If there is already positive, then the result will be that. So basically the modulus function says if you are having a negative number, output will be your output modulus of x will be, if it is negative, your output will be minus, like if x is something as a negative, then whatever you are having, it will just give one more minus sign and then minus x, and that's why it is becoming positive, right?
Yes, ma'am.
If you know the graph of a modulus function, it looks like this one. The function of x for the modulus function looks like f of x is x when x is positive, and f of x is minus x when x is negative. So when your x is negative, one more negative sign it will give, and that's why you are getting eventually a positive answer. When you were in lower classes, we used to say it will always give a positive value, it will always give a positive value. How it is making it a positive value? Because when x is negative, it is giving one more negative sign, and due to that, your final function, your final value is becoming positive. When x is positive, it is just giving the same output. Okay.
Yes, ma'am.
That's the meaning of the modulus function. So here we can say, since x is there, so obviously two cases can be there. What are those two cases? Mod of x plus 2 is greater than 0. If it is greater than 0, then the same result will come out. So our equation x square minus mod of x plus 2 plus x, this will become x square minus, the same thing will come out. No need to change the sign when the modulus value is greater than 0. Is it clear?
Yes, ma'am.
Yes, ma'am.
And another case will be when it is less than 0. So when modulus, this one is already smaller than 0, then what I said to you, the function will give one more negative sign. So x square minus mod of x plus 2 plus x, this will become x square minus of, again one more minus sign, x plus 2 plus x. Is it clear to both of you?
Yes, ma'am.
Yes, ma'am.
So these are the two cases. Case 1 can be that, and case 2 we are having this one. Now we will be solving each and every case carefully, and we will try to figure out what is the interval we are getting from here. So let's solve this. X square minus x minus 2 plus x is greater than 0. Is it okay? So here
Yes,
x
ma'am.
and x will cancel out each other. We will be having x square minus 2 greater than 0. We will be having x plus, we will be having x plus root 2 a plus b and a minus b. Are you getting it?
Yes, ma'am.
Do you know wavy curve method to solve inequality? To get the
Sorry,
range of
ma'am.
inequality? Do you know that?
What method?
No, ma'am.
Wavy curve method.
No, ma'am.
Let me show you here only. To solve the inequality or to get the range of the inequality. So basically you must have done this thing like getting the intervals and all by using a long process. Here we are going to first discuss about the short trick. What will be the short trick? So just a moment, let me take few examples. So let's say we are having a equation that is x minus 3 and x minus 5. That is greater than 0, and here we have to find the range of x, like in which interval x is lying, that we have to find. So first thing first, what we do, we will find the 0 of each and every bracket. 0 of this one and 0 of this one. 0 means like x minus 3 is equals to 0, then what will be the value of x? X will be 0 at which value? So 3 we are getting and 5 we are getting, right? Like without even solving, we can see x is 3 and x is 5, right?
Yes, ma'am.
Now we will be plotting a number line or a real number line, we can say. We will be locating our 0. So x value is 3 and x value is 5. Properly we will be locating because we know 5 will lie on the right of the 3. Now this 2 multiplication between these two is greater than 0. That means both can be negative or both can be positive, right? right?
Sorry, sir, ma'am.
Like if something is greater than 0, that means greater than 0, that means if both are negative, then only it will become negative negative positive and will be greater than 0. Or if both are positive, then only it will be positive positive positive, and that means greater than 0, right?
Yes, ma'am.
If one of the number is negative and another is positive, will you get the result as a greater than 0?
No, ma'am.
No, ma'am.
No. So two possibilities are there. That is both, since our inequality says that x minus 3, x minus 5 has to be greater than 0. That means the first bracket must give the first bracket, if it is giving a negative number, the other bracket also must give a negative number. Then only it will be greater than 0. Or the first bracket is giving a positive, then another bracket must give a positive value. Then only it will be greater than 0. Right?
Yes, ma'am.
Yeah. So here, if we will be taking like this one is a real line. Here we can see the interval minus infinity infinity. Now if you will be taking any value in between, let's say minus infinity to 3. So, and if you are taking any value in between minus infinity to 3, so we will choose such a value which will help us to like do the calculation easily. So 0 if we are taking, so this first bracket here only we will be able to analyze without even writing everything. Okay. So the first bracket x minus 3, if you are taking 0, this will be negative, right?
Yes, ma'am.
And this will also be negative, right?
Yes, ma'am.
So here you are getting a positive value. Got it?
Yes, ma'am.
Now in between 3 and 5, if you will be taking any number, let's say you are taking 1. Okay. So the first bracket will give you negative or positive. 1
Answer
minus
will be
3,
positive.
negative. 1 we have taken as a test point. X value as a 1. Okay.
Yes, ma'am.
Now the second bracket will also give you negative or positive. Okay. Why we are taking 1? Just a moment. In between 3 and 5, 1 is not there. In between 3 and 5, we can take 4, right?
Yes, ma'am.
Are you getting it?
Yes, ma'am.
Any confusion?
So
No.
we find solutions for this. That's it, ma'am.
Yeah, what?
We just find solutions in like the normal way for inequalities in the wavy curve method.
Yeah, in the wavy curve method, we just find the solution just like a normal way while taking the test point. But here we will realize one thing, that it will always come out as a plus at the right, like the maximum value you have written 5. It will come out plus over here, it will come minus over here. Then again it will come out, just a moment, this 4 was not there. Yeah, so we will see a pattern over there, that here plus will come out, then minus will come out, then plus will come out. What we need greater than 0. Okay, that means positive value we need over here. So our interval will be this interval and this interval, and it will look like wavy curve. Directly, without even taking the test point, we will be just drawing the number line, we will be just locating our points, and we will be able to say that okay, it has to be greater than 0. That means we need the positive ones, and the interval will be minus infinity to 3 union 5 to infinity. Here greater than sign is there, greater equals to not there. So that's why we will be taking only open intervals. Directly, without even taking the test point, we will be getting that. Okay, let's do it quickly for few more questions so that you will understand the pattern. So suppose I am having x square plus 4 less or equals to, okay, this is minus 4. x square minus 4 less or equals to 0. Okay, here first thing first we will be factorizing it. So x as much as possible, x plus 2, x minus 2, less or equals to 0, it's okay. What are the zeros of x? The solution will be getting x as one of them is 0, another is minus 2, another is plus 2. Is it clear so far?
Yes, ma'am.
Yes,
Okay,
ma'am.
we have just located it. Now what I'm saying, when this pattern will be followed, x minus 2, x plus 2, this pattern will be there, then the right hand side, the extreme right will be plus, then minus, then plus, then minus. This pattern will be followed. Okay,
Yes, ma'am.
now our wavy curve will look like this one. Upside, you without even drawing the wavy curve, you will be able to understand. No need to draw the curve. Okay, it's just one more thing we are adding over here. Now what we need, less or equals to 0. That means this interval, the negative one, and this interval, the negative one. Can you see both the interval?
Yes, ma'am.
Can you see it? Now we will be taking minus infinity to minus 2, and we will be taking the other negative, that is 0 to 2, directly without even doing anything. Test point and all, this is short trick. We are not taking the test point and all. This pattern, if this type of factorization is there, then directly we can take plus minus from the extreme left, from the extreme right. Okay,
Yes, ma'am.
and this is the interval. Now here we are having inequality sign, where equality is also there, like less and equal is there. If you have done inequality chapter, you know the graph of such function looks like there is a solid circle over there, right? A solid circle over here, a solid circle over here. When we are drawing inequality for x greater or equals to 2, the graph of that will be 2, a solid circle, and then this side, right?
Yes, ma'am.
So for this, the interval will be 2 to infinity. A close interval will be there at 2, right?
Yes, ma'am.
Similarly, since here also we are having a less or equals to 0. Less or equals to 0 is there. That's why we will be taking close interval, close interval, close interval, union. Is it clear?
Clear, ma'am.
So this is how we will be finding this type of factorization by wavy curve method directly. Okay, so similarly for our question, what are the 2 points? The points are, one is minus root 2, another is plus root 2, right?
Yes, ma'am.
Plus, minus, plus. Here we need greater than 0. So the interval x will lie in the interval minus infinity to minus root 2 union root 2 to infinity. I'm not taking close interval because here inequality sign is only greater than. Is it clear to both of you? Directly we have taken it out.
Yes, ma'am.
Yes, ma'am.
Just a moment. Yeah. Now, since we are having here one more case where we have written when modulus is less than 0, then it will give the negative output. So here we need to solve it again. That is plus x plus 2 plus x is greater than 0, right? That
Yes,
means
ma'am.
x square plus 2x plus 2 is greater than 0, right?
Yes, ma'am.
Just a second. So if we will find the solution of this one, what will be the solution of this one? Like if we will try to solve this, Is it possible to factorize it?
Yes, ma'am.
Is it possible? If we will be if we will be solving this quadratic directly by formula method, what we will be getting? We will be getting x is equals to minus b plus minus under root b square minus 4ac. That means 4 minus 4a into c. That means 8, right? Right?
Yes, ma'am.
So here you can see we are getting imaginary root. Can you see 4 minus 8 will be negative 4, and then a square root negative is imaginary complex number.
Yes, ma'am.
And here the question says real number only we need. So the other case is not helping us. Only the first case is showing us that the range of x or the interval of x will be minus infinity to minus root 2 and root 2 to infinity. So minus infinity to minus root 2 and root 2 to infinity. This is the option, correct option. Getting
Yes, ma'am.
any confusion over here?
No, ma'am.
Okay. Let me take few more questions. The question says the number of solution of log 4x minus 1 is equals to log 2 x minus 3 is 1/3, 1, 3, 2/3, let me check whether the question is this one only or not.
Okay, ma'am.
Log 4x minus 1 is equals to log 2 x minus 3. Okay. So yeah, this is the question we are having, and we have to find the number of solution. So let's write it. Log 4 x minus 1 is equals to log 2 x minus 3. Here the bases are not same. That's why from here, like going ahead, like we are not able to go ahead. Can you tell me which property of logarithm we can apply over here so that we can go and simplify both the sides very easily? Any property of logarithm which can be applied over here? It's just like solving the equation having logarithmic function.
Log A minus B.
Log a minus b can be done, but this has to be same, right? Like log m by log n is there, then directly we can write log m minus m, but the condition is the basis has to be same, right? Whatever property you have learned for logarithm, that multiplication becomes addition, division becomes subtraction, everything is applicable for same base. Here the bases are not same, so that's why first thing first we need to focus on how to make the base same. So we can write it here 4 is there, here 2 is there, so we can take 4, both side we can take 4, and we can take the power logarithm 4x minus 1 is equals to, again here also, like anything whatever you are doing on both side of a equation, that is allowed in mathematics. So here we are taking x minus 3. Same thing we have taken here. I have taken 4, and this logarithmic function I have taken as a power of 4. Same thing I have done over here, right?
Yes, ma'am.
This one can be done. Okay, if m is equals to, let's say x is there, then I can write 2 to the power m is equals to 2 to the power x. Eventually this and this are same, right?
Yes, ma'am.
Yeah, so that's what we are doing over here. Now here 4 log 4, this will just cancel each other, and we will be having only x minus 1 over here, right?
How,
Right.
ma'am?
Yeah,
Can you please send again?
there is a property that a log a and then x is equals to only x. This a log a will just cancel out each other.
Okay, ma'am.
Getting?
Yes, ma'am.
Similarly, here we are having, here we will be having 4 log 2. This we cannot cancel. We can write 4 as a 2 is square. We can write 4 as a 2 is square, and that's log 2 x minus 3. Is it clear so far? Is it clear?
Yes, ma'am.
Here we will
Yes,
be
ma'am.
having x minus 1, and there we will be having, there we can multiply both the powers. So we will be having 2 to the power 2 log 2 x minus 3, right?
Yes, ma'am.
So here we have just done the multiplication, like a to the power m to the power n is equals to a to the power m into n. That's what we have done over here with this two. Okay, with this two. So basically on the left hand side, or yeah, on the left hand side whatever we are having, let's keep it as it is, and here we will be having 2 to the power this log 2, and this whatever is in front we can also write it as a power, right?
Yes, ma'am.
Right, so we can write it as a x minus 3 whole square. Can we? Because whatever
Yes,
is
ma'am.
power, that usually comes in front. So if there is something in front, we can write it as a power. right? And now only we have discussed that this one will give us, like it will give us 1, right? Only x minus 3 square will be remaining over here. Getting it?
Yes, ma'am.
And here x minus 1 is there. So now we just need to simplify it. We just need to solve it. And we need to check how many x values we are getting from here. So x minus 1 is equals to x square. And x square minus 6x plus 9. Let's do it quickly. So x square minus 6x minus x minus 7x plus 9 plus 1 plus 10 is equals to 0. Let's see whether we can factorize it or not. We will go for formula method, but first thing first, we will be checking whether factorization. I can see 5 and 2, we can break it, right? Can we?
Yes, ma'am.
So here we'll be having x minus 5 in one bracket, and in another bracket we'll be having x minus 2 is equals to 0. So we got x value as a 5, we got x value as a 2. Two values we got for x, 5 and 2. Okay. Now here we were having the question, we were having log of 4 x minus 1 is equals to log of 2 x minus 3. If we will be substituting 5 over here, then we will be getting log of 5 minus 1, that is 4 base 4, and is equals to log of 5 minus 3 2 base 2. This is okay. Okay, both side whatever we are getting, that is completely fine. Let's substitute 2. When x is 2, then what are we getting from the original equation? So from the original equation we will be having log 2 minus 1 1 is equals to log base 2 2 minus 3 negative 1. Negative of logarithm is not defined. Getting it?
Yes, ma'am.
So this x is equals to this value 2. We have to exclude it because it will make our equation, it will make the given condition undefined. We cannot take that. So how many value of x we got? Only one value which will satisfy it. Okay.
Yes, ma'am.
So even though we have got two values, but we will be saying the number of solution will be 1. Okay.
Okay, ma'am.
So these are the uh, process which we need to follow. Now from next class, uh, a lot of concepts which are related to quadratics and all, the sum, the product, the nature of the root, and along with that few extra questions which are related, which in which we have used other concepts also, like if in the previous class we have used the concept of cosine, the rule of cosine and everything. So that also today only we were using geometric progression also. So these are few different types of question which we have solved over here. Now you solve this chapter from anywhere. If you are getting any question, try to solve it, and if you cannot, do ask in the class. We will be taking those questions and we'll be discussing. From the next class, I'll be moving ahead with the sequence and series. Let me confirm which chapter we will be starting. Yeah, from the next class, I'll be starting sequence and series. Okay.
Okay, ma'am.
So yeah, we will be discussing that topic in detail. Just like this one, we will be taking the question, but first we will be seeing the concept and the theories, whatever is applicable, the theories which are related to, which will be helpful for JEE preparation. That theories first we will cover, and then we will be taking the question once we will start that chapter. Okay.
Okay, ma'am.
Okay, so I am keeping it this much. If you want to ask anything, please do ask.
No, ma'am, no doubt.
Okay, so yeah, keep practicing. And next class we will be starting sequence and series in detail. We will be starting with the theory portion first. And meanwhile, I'll be taking the questions which are related to the theory which we have discussed. So like that, we will be taking the like that we will be proceeding over there. Here, since the theory, not that much theory was there, the sum of the root, product of the root, nature of the root, and few extra things were there. That's why we did everything along with the questions. There we will be taking the theories of course. Okay.
Okay, ma'am.
Okay. So yeah, keeping it this much. Till the next class, take care of yourself. Thank you, both of you.
Thank you,
Thank you,
ma'am. Bye,
ma'am.
ma'am.
Yeah. Bye.